when I talk about angles, what makes up an angle?
Lines.
More specifically, two rays, correct? Now, some people will use their arms. To get that shock factor out, I always say it's the distance between two legs. Distance between your legs. Now, I know that's probably crossing the line, but it sticks in heads a lot better. Okay? So, we will talk about some terminology today. We got to get on the same page with our terms.
That's not weird.
Here is a coordinate system. We will have 4 different areas, thus called the 4 quadrants. Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. It goes in that direction, the counterclockwise direction. Okay? If you're not sure, you can kind of look up here. I don't know if I have the 1, 2 on here. Oh, look at that. No radical butts. I forgot that was there. All right. We'll use this a lot. This was a dime purchase. Somebody paid a dime at a garage sale for that. It's been around for 20 years. I've only blown it up once, Lydia. That's amazing, isn't it? Kennedy, how many times do you think it would deflate? Twice? 3 times? 0. You're right. Good. Okay, so when we are talking about degrees, we are going to work with this coordinate. This is called your standard position. It's where you start every single time. One of your legs will be in the initial side. Initial side is one of the legs. And it will always be in standard position. Okay? Now, if we move upward, that is positive. That's a positive degree. If we work downward or clockwise, that is negative. So, if I am going to draw an angle in standard position with the initial side here, and this is called your terminal side, where it stops. So when I say, hey, what's the degree measure? Well, you know a couple things. One, it's positive. What else do you know? Think of your geometry days if you need to.
It's acute.
It's acute. It's acute angle. What's acute mean?
Less than 90.
Less than 90 degrees. What's directly in the middle?
Does it start with a B?
No, it starts with a 4.
45.
45!
Oh.
What's straight up?
90.
90 degrees. Anybody know what the standard incline, decline, whichever way you look at it, of a slide at a park is? Ooh. 40 degrees. 40 degrees.
That's what
Straight down.
90. Someone said 90 last hour.
Did they really?
Yeah.
Just in case it is so.
Yeah, that'd be a tough one to go to. Anybody know? Well, the incline of my driveway at home, 27.2 degrees.
That's a pretty steep drop.
27.2 degrees.
Mine's like
No. What about for handicap ramps? What is it?
40.
It is not 30, it's less. 22.8. Can't go any more than that. Good. All right, so we can kind of guesstimate. Here's our initial side. What if I went with this? What kind of angle is that? There's my terminal.
So,
Oops, let's get rid of this so you can't see it. Now what? Black.
That's nice.
90 degrees. Oh, what if I kept going? Now where am I at? 180. And if I keep going?
36. Wait.
270.
Yeah.
And if I keep going?
360.
360. 360 and what are the exact same? 0. Awesome. 0. Now, ladies and gentlemen, when I was 14, that was my nickname, 360. As I got a little bit older and studied trig more in depth, then they changed it to 2 pi, which you'll understand here in a moment. The reason I had that name is because of my basketball skills. Not a lot of people know that about me, but I am, I was a legend in Davenport, Iowa. On Saturday afternoons, people from all over the city would come and play basketball at Peterson Park. And I had things drawn out because I was kind of into math, a little geeky. Don't tell anybody that.
It's on video.
So I should have said to myself, don't tell anybody. But if I was going right at a basketball hoop, I had that, and then I had a different angle. I called this a 30-degree angle. I used to call it my 30. And this was my 150. I don't know why. Just the way I rolled. That isn't exactly correct. So if I came at an angle and I just went the dunk, I'd go, that's my 30.
Oh my gosh.
Doesn't matter. I chased a woman for 7 months. Do you think I really care?
Okay, that's commitment.
I mean, I'm just surprised you'd actually dunk.
Oh my gosh, watch this one. I used to come in at the 30. I'd do the crossover. Because this was in between games. A lot of people shoot. Not me. I just put on my clinic. Boys, sign on up because I'm getting ready to put on a clinic. Come. And then I come up.
What's the snake? What's the snake?
10 foot. So I just did a 30. No, I didn't. What did I do?
360.
It started at 30, dude.
Oh.
Duh.
390.
390. I did a 390 for all the smart kids out there. But there was a lot of kids that were sagging their pants. And then I come in at that 30, and instead of going that way, guess what? What was that?
330.
Negative.
330.
Negative 330. Those are the exact same thing. Look. I'm looking at you. I'm looking at you. What am I doing? What are those called if you do a complete circle? 360s, correct?
Yeah.
And I'm ending up in the exact same location. That's called coterminal. Ending in the exact location. Different degree measure. Stanley, that time, I want to party with you. Oh, 360s all the way around. I mean,
That was a monster.
you did. You stand in the front yard, the people would drive by and go, what's wrong with that kid? You just go, ah! Ah!
Well, I was on fire, to be honest.
I saw a movie where a kid's leg caught on fire while he was hitting on a chick last night.
Project A.
No, I never seen that movie. I'm not really into that.
Projects is an awesome.
No, it was that Zac Efron guy. 17 again?
He's a girl.
Oh yeah, I watched it TBS.
Yeah,
Yeah.
I was flipping. I haven't seen it. It's kind of a
Chick-
weird.
yeah.
Yeah, it's kind of good. Okay, so if I say, hey, 60 degrees, coterminal, I'm at 60 degrees. What degree measure am I at now?
420.
420. I did a complete circle. What if I said I want a negative coterminal? Which way am I going now?
Left. Right. You're right.
Now what degree measure am I at?
Negative
Negative what?
420.
No. Negative 300. Take a look. 60 degrees is right there. So if I start at my 60 degrees, I've gone 60, 360, plus 60 more. That's where the 420 comes from. If I start here, notice I'm drawing arrows in the direction that I'm going so everybody knows I'm going positive. Let's get positive. Now I'm going to go negative. Negative 180, negative 270, plus some more, and now I'm at negative 300. Anybody figure out a shortcut? Add 360, subtract 360. That'll get you coterminal every single time. Maxwell, does that make sense?
Yes.
Good. So, what do we do here? I want a positive and I want a negative. I want a positive coterminal and I want a negative.
So 40.
760.
You
is
could do
positive.
760. You could also do 40. Absolutely. Those are both positive. They're the coterminal. What about my negative, though?
I don't even know. Is there a negative in the 40?
Just go around twice.
Just go around.
300.
Emma G. Go, say it again.
300.
I think it's negative 320, isn't it?
Yes.
Yes. Emma G just grabbed her calculator. You know what she did? She put in 400, she subtracted 360, and then subtracted 360 again. That's all she did. You can do that. You will be asked to give a positive and a negative, Blake. I know you're always looking at the positive, but I'm going to ask you to step outside your box.
All right.
All right? Now, we're going to back up. Could you draw a 210-degree angle, yes or no?
Yes.
I hope so. Here's my coordinate system, plane, whatever you call it. Where's my initial side going to be?
The third.
There it is. Which way am I going if it's positive?
You can go to the third quadrant, right?
You're going to go up. 180 is there and a little bit more. Use common sense. Please draw an arrow or a squiggly to show that you're going in that direction. Okay? What about 500? Ooh. Johnson?
Go through 60 and then go.
Sam, this is letter B.
Apologize.
Not 13. Okay, here we go. $360. What's this?
450.
400. Today, another 90. Just add 9 to 36. 4 nines. 5 nines. What's this going to be? 6 nines.
540.
540. Thank you for knowing your multiplication facts. So 500 is in between those two. So we are going to approximate a little bit. We aren't going to be perfect, but we'll be pretty close. Just because that's how you guys are. I know you all have mirrors.
Is that how we draw it? Too?
Yep, you got to have some squigglies in there to show the direction that you're going. Looks like a shell. So we have to have Shelly. Murph, you all right with that? Oh.
If it's negative, do you go the other direction?
Let's find out. Jace?
Wait, so are we trying to get all 4 of these angles that we're drawing to get to the same spot, or what? I just don't understand what we're doing.
We're drawing a 500-degree angle.
Okay.
So what it really is this. But I'm just showing the direction that I'm going to get there. So if I do a negative 120, I'm going to start here, and I'm going to go this direction, draw my negative 120, and be done.
Oh,
Okay? 570. I'm going to start. Again, everything starts in that initial side, standard position. 570, there's 360, 450, 540, and a little bit more. Done. So it's common sense, or logic, I guess would be a better term. Okay? Question on that? Alright, the other thing that we're going to deal with is, I told you my nickname was 2 pi, because I kept doing all those 360s. You know why they converted it to 2 pi?
Because it's the L360.
It is the other 360. That's right, it is. We have to be able to go from degrees, and 2 pi is radians. You have to be able to go back and forth. Radians deals with circles. What else deals with circles? What did you always have in circles? Diameter, radius, what else?
Circumference.
Circumference. I'm looking for a symbol. You eat it after Thanksgiving dinner. Pi. Radians deals with circles. Circles you must have pi. Circles pi. Circles pi. Pi circles. Radians pi. Say it with me. Radians pi, radians pi, radians pi. Go ahead, Bucky. Radians pi. You know, like you hold a beer can, correct? That's a radius. You're going to have a circumference. You're going to deal with pi. Okay? What did you say? Alright, Toby, sorry about that. I apologize. I'll try not to record that, okay? Radians.
Hi.
Circles.
Pi.
Hi.
I see how this works now.
Radians.
Pi.
Hi.
Pi.
Circles.
Hi.
Jung.
Hi.
So, ladies and gentlemen, I have a circle here. I have a circle here. If we look at this circle, we can cut it up into those quadrants also. We have to be able to go from degrees to radians. Anybody know how to do that? What did we say? Radians has pi. So we're going to have a pi in here somewhere. Guess what you multiply by to convert to radians? Anybody want to guess? Close.
Sense.
3.
Because what's your diameter?
180.
180 degrees, right? So, if I was going to convert that, guess how many times 45 goes into pi? Excuse me, into 180. 4 times. So, 45 degrees is the same as pi over 4. It's the exact same thing. So, if you're going to say, hey, I'd like to cut that angle at 45 degrees, you can be a smart mouth and say, I'd like to cut that as pi over 4, please. Because it's funny. What's 210 degrees in radians? Times pi over 0's Gandhi. Reduce. Divide by 3. Just leave it as 7 pi over 6. Don't write 1.16666 pi. Nobody does that. Kennedy, stop it. She's back there erasing. What if I give you a radian and I say, hey, I want this in degrees. What are you going to do? Ooh.
So you actually want it in degrees now?
Now I want degrees. Do degrees have pi in it? No, so let's get rid of pi. How am I going to get rid of it? Put a pi on the
Bottom.
Anybody know what goes up here? See ya. What's 5 pi over 3? That's a 3. 300 degrees. Why do we have this? Last year you found distance around parts of a circle and you used these proportions. You guys spent a lot of time doing it. It took a long time. I'm going to show you a shortcut that takes 38 seconds. What do we have here? What figure? Circle. What are we going to deal with then? Pi. This represents, it's called theta. It represents an angle. So if I tell you that this is 60 degrees,
You could just convert that to. That sucks.
you have to convert this to radians. Anybody know what that is off the top of your head? How many times is 60 going to 180?
3.
3. So guess what this is equal to? Pi over 3. So, what's my radius? 8. So to find the distance from here to here, I just told you. That's the information I'll give you. So. I just pulled it out.
I thought you got that from the pie.
No. It's just made up. This is number 13 in your book. Okay. So to find this arc length, I'm going to take the radius times the interior angle, which is theta in this case. Anybody know what 8 times pi over 3 is? 8 pi over 3 and leave it. Walk away. Walk away. Walk away quickly. Or do your circle dance that you used to do. One of the two. Area. Same concept. We'll take that same circle. We want to find out the area. I'm telling you this is 60 degrees, radius is 8. There's your formula. These two are formulas. So to find the area, 1/2. What's my radius? Square it. What's theta?
60.
No!
5/3.
Pi over 3. Do not think about using degrees. It's a circle. Pi! Circle? Circle? Circle! I would just write 32 pi over 3.
Oh. Close.
What is the circle represent?
The theta?
You gotta
The
record.
theta is the degrees. Kind of like the circle with the lines.
It's on the blog.